Module 4, Lesson 4, Model Building. So in this step, we are going to build our model. And the first thing we need to do is to get this data that we found are direct attributes that correlate to our value score here. So this value score will store it in an y variable, and these other values we store them in an x variable. We are doing this since we are going to use the logistic regression algorithm. In this data that we are working, the logistic regression algorithm will be the most effective and the most efficient to use in this situation, since we are trying to see how these other data here affect this guy here. Logistic regression becomes effective and efficient in this situation. So the first thing you do is to get the y value, which is the score, and the x values, which will be the other values that correlate to y value. In this case, let us just say y is equals to world underscore happiness underscore file, and in this case it will be the score. As simple as that. Then the x values will be world underscore happiness underscore file. But in this case, if you can remember, in order to store all these values in one variable, we can use the log function. If you can remember, we learned while learning the Pandas package. If you can remember the log function. So now what you're doing here, let's just also up here, let us just use the log function. We'll be picking everything in this case. So here I will not put anything. This means start from the first guy to the last guy in these records and pick only the column that has this title score. So I'll do the second guy also like that, and I'll just do like that. But in this case, we'll pass the name of this guy that I'm going to use. In this case, we shall have, this is GDP per capita is the guy that we are going to use. Let me just do like this. This will be GDP per capita. We also have this guy by the name social support. Our third guy will be, this is healthy life expectancy. Let me just move up here and copy these guys. This will be healthy life expectancy. Let me just copy him and come and paste him down here. Paste that guy here. And our last guy, if you can remember, will be this guy right here. This is freedom to make life choices. So let me just copy also this guy right here and come down here and paste this guy right here. This will be like so, and there we have it. Now we'll store all these guys: GDP per capita, social support, healthy life expectancy, and the freedom to make life choices. These guys which correspond to this other guy's score. So this other guy's score will store him in an y variable, and this other guy will store them in an x variable. After that, let us just run our code and see what happens. Oh, sorry, this should be square brackets here. And so let us just run our code and see. So our code is good. If it has run and there is no error, it means now we have this value in y and we have also these other values in x. So now we can proceed to the next step. And the next step is whereby we split this data into a training set and into a testing set. And the reason we do this is that we want to create a model from this data and train that model. After training that model, we want to test our model again with some data to make sure that it is good and it is working effectively. And if there is any error, then we can make an improvement on that. That is the key reason why we split our data into our training data and into a testing data set. One small thing I've just forgotten: make sure you add this dot value to your function up here, the log function, and also to this second log function, make sure you add this dot value. So let us go to the next step, where you'll be splitting your data into the training dataset and the testing dataset. Both of these datasets should have both the x and the y variable. And before you do this, it is good to know that there are two methods of doing this. But I will start with the most easiest and the most efficient, which is easy to use. Then I will show you the other one, which you can use when maybe you have forgotten the first one, or you don't see if the first one is that efficient. So the first thing you do in this first method is to import this guy by the name sklearn.model_selection, like so. Then you say import train_test_split. Very simple like that. Then we'll have x for the training dataset. Then we'll have x for the testing dataset. Then we'll have y for the training dataset, and last we'll have y for the testing dataset. So this is very easy. So the next thing you do here is say equals, then you copy this guy up here and you'll come and paste him down here like so, and put your rounded brackets. Then you pass these variables here, x, y, the next guy you pass here is the test size. Let me just write test_size. Let us say it'll be equal to 0.25. So what this means is that when you set this to be 0.25, it means split your data into 0.75 to be the training dataset and 0.25 to be the testing dataset. This is done automatically by your function here. So you can split your data either to 80-20, 50-50, but usually I prefer splitting it to 75 and 25. 75 for the training dataset and 25 for the testing dataset. And the last guy here, you just say random_state, and you just put this guy to be equal to 0. What this means is when splitting this data, do not split it in a certain format, but the 25% should be just of random values from the whole dataset. Also, the training dataset should consist of random values. That is what this means. So this value here will return 4 variables, which will be stored in the x training, x test, y train, and y testing dataset. Now let me show you the second method by which you can use, or rather apply, in order to split your data into training dataset and testing dataset. The first thing you need to do is, of course, to shuffle this dataset that you have, or let me say this data that you have, so that you do not split your data into a certain format that will be biased. And the way you do it, let me just type here, just say shuffled data should be equal to world underscore happiness underscore file. Then you use a method by the name sample, and inside here just write frac equals to 1. As simple as that. So the next thing now you want to do is to take this shuffled data and split it. Let us say the first 100 data goes to the training dataset and the second data goes to the testing dataset. And the way you do this, very easy. Let us say x for this course, x training, x train, like so. We also need x test. Remember, we also need y train. Lastly, we need y test. And if you think of x, let me just copy this guy so that I may not do so much here. I just copy this guy here. So the x train will be this. Let me just paste this guy here. So the x train for this course will consist of the first 100 record of all these guys. So here, instead of leaving it blank like this, I'll just leave the first one blank, which it means start from the first guy up to the 100 guy. And instead here of writing world happiness file, I'll just pass my shuffle data here now. Instead of using unshuffle data, I'll just pass my data here like so. Let me just copy this guy, and just paste him here like so. And then let me just now copy this guy and paste him here, and just remove this guy. So our X test, if you can think of it, will consist of the data 100 going forward. So instead of leaving here like that, I'll just put here 100, which means start from the 100 up to the last one. I hope that is understood. Then the Y data, I'll just copy this guy again now, and I'll just come and paste him here like so. But now I'll use my shuffle data here and come and paste him here like so. And also let me just now copy this guy and paste him down here like so. But now this guy again will start from 0 to 100, and this second guy, Y test, will start from 100 until the last one. So this is the second way you can split your data manually. But I would like to recommend that you use this first method because it is kind of more clean and more efficient and more professional when using it. But this other guy, you can use him, but preferably you can use him when this other guy is not available. So this is the second way you can be able to split your data into the training dataset and into the testing dataset. So the next step that we are going to see is how we can now create our model. I've just commented this guy out. We do not need him. I'll just be using these first guys. So let us see now how we can create our model. Creating a model, in this case, it will be very easy. And the first thing we need, of course, we need the logistic regression algorithm. And this logistic regression algorithm is found in the linear model package. So the way you import it, I just say from sklearn import linear model. Let me add a comment up here. Say importing linear model algorithm. So once you have imported this, just run your code, and down here create a variable. In this case, the variable that I will create, I'll just say, let's say regression. It will be equal to, now you want the logistic regression algorithm which is in this model. So the way we'll get this linear regression algorithm, we just type linear model like so, dot linear like so regression. As simple as that. And then now, if you can think of it, we need to use this regression variable that we have just created here and call a method by the name fit. And inside this fit function, we pass our training data, that is the X train and the Y train. As simple as that. X train, comma, Y underscore train. After you have done that, you are good to go. Just run your code. You can see down here, it prints something linear regression copy and blah blah. When it prints these things down here, this comment right here, it means your model has been successfully created. So the next thing we do now is to test our model that has been created before we actually see visually how this model looks like and how we can apply it. So let us test our model using the test data. In testing, what you do is that if you can look up here, we have the Y test and we have also the X test. So what we do, we use our model and then we pass this data into our model, and then we store that result in a variable. Then that variable, we compare it to this Y test to see if they match. And if to a greater degree they match, we can conclude that our model is very, very good, and also we can see the improvements that we can make in this model. Very simple. We pass this X test data into our model, and then it will predict the result for this Y test. And then we'll compare between this Y test and the result it has been predicted from the model. That is how now we can be able to test the accuracy of our model. Let me just add a comment here and say testing the model. So the first step here is that I'll create a variable which will be Y prediction, that the model will predict from our X data. So in this case, you use this guy that you have just created up here. In this case is regression. Then I'll call a method by the name predict, like so. Then inside here, I'll pass the X test. So I use my model, I pass the X test data, and then it will create some data here and store it at Y. Then this data should correspond to the Y test. So if they match to a greater degree, then I can conclude that my model is very, very good and its percentage of accuracy is high. So if you can see, if I print down here this guy by the name X prediction, and if I run my code, you see it prints some values down here. And what it has done is simply, I've just passed this X data and my model has just predicted and said these should be the values that correspond to Y for this X data. So I need to compare this data with my Y test to find the accuracy of my model. So as you have seen, the way we find the accuracy of our model is to take this Y prediction and compare it to this other guy, this Y test here. And so the way we do it is very simple. The first thing, let me just write here, create a variable prediction underscore result. And so this variable will be a Pandas data frame. So I just write data frame. If you can remember, we use the rounded brackets. Then inside here we'll be passing a dictionary, and the first guy in this dictionary will be the actual data, and so this will correspond to the Y underscore test. And then the second guy will be the predicted data. This guy will correspond to the Y prediction, like so. Then down here I'll just create another new attribute, prediction. It should be prediction, like so, underscore result. This attribute will be difference, so that we can see the difference between these two data. This will be equal to Y test minus Y prediction. And then I'll just print the head of this guy, prediction result. I'll print its head down here so that we can see what is happening. This should be rounded brackets. And so if I run my code, you see what is happening down here. I have the actual data, the predicted data, and then the difference. So you can see, for example, here we have 6.43, 5.6, the difference is 0. So actually this difference between the predicted data and the actual data is not very, very good. It is kind of huge, and there are ways which are more advanced. If you want to see these ways in which you can utilize in order to improve the accuracy of your data, you'll find in my intermediate course. But for now, this is how you check the accuracy of your data. Our model is kind of good, but not that very good, because this difference 0.7 when you consider it in a larger scale, it will affect your data very, very much. So that is the way you check the accuracy of your data. To further evaluate the accuracy and the efficiency of this model, we can print also 3 other values, and that is the mean absolute error value, the mean squared error value, and the variance value. When the mean absolute error value and the mean squared error value are less, that means your model is more accurate. For example, if today I create a model and I evaluate this value, and tomorrow I also improve on these models, and the value for tomorrow are less as compared to the value of the model which I built today, then it means the accuracy of my model has increased. But if these values increases, then it means the accuracy of my model has decreased. But the variance evaluates the score of the model in a range of 0 to 1. That is, for example, if the variance is 0.6, the accuracy of my model is 60%. If the variance is 0.9, the accuracy of my model is 90%. And if the variance is 1, the accuracy of my model is perfect. So the way we do this, the first thing you need to do is just to say from this guy sklearn dot, you type matrix, as simple as that, and then you import this guy by the name mean underscore absolute underscore error. Then I just put a comma and import this other guy. This should be mean squared underscore error. As simple as that. Then the first thing you do here, I'll just print the mean absolute error. And so I'll just copy this guy here. Let me just copy this guy. Copy this guy, I'll paste him here, put my rounded bracket, then I'll pass the y underscore test, and this guy is y underscore prediction. And then let me just copy all of this guy now and come and paste him down here. Then this will be mean squared error, and I'll just copy this guy right here, and I just now come and paste him here like so. The second last guy that I'll print will be a root mean squared error. That is the square root of this upper guy, this mean squared error. I'll find its square root and print it down here. So what I'll just do, in NumPy we have a function sqrt which means find the square root. So I'll just copy this guy here. There is nothing fancy here. You just copy these guys and paste them here. It's just like finding the standard deviation of a particular model. If the standard deviation is low, the model is more accurate. If it is high, the model is poor and not very accurate. Then the last guy I just print here, just let me add a comment and say the score of the model, like so. So the score of the model, the way I just print, I just say print, and I just pass here, this will be variance, and so just pass, this will be percentage 0.2 f, like so. And then I'll just, on the other side, I'll just write in bracket like so. And the thing that I'll just pass here, first of all, you need to have this percentage sign out of these brackets. And the thing that I'll just pass here, I'll pass our model. If you can remember, it was called regression dot, but now I'll just type score, and now I'll pass in x test like so, and the y test guy. So what I'm doing here, I'm using my model to evaluate what score it will get when trying to predict this data on X test. Remember, we separated this data for the test data and also the training data. But now here, after training my model and building my model, I'm now testing it to see the score that it will get on this testing data. And so as simple as that. After doing this, let me run my code and see what we'll get here. So down here, you can actually see that the mean absolute error is 0.54. The mean squared error, this is 0.4, don't know what. Then the root mean squared error is 0.6. This model is not really good. And for this reason, actually, you can see that the score it got on the test data is 0.6. That is 60%. And a very good model is considered to have a score of between 0.7, that is 70%, to 100%. So this model, we can check on how to improve it, but that is more in detail in the intermediate course. One more thing that we can actually do here is plot the actual values against the predicted values. Let us just draw this before we proceed and use the Seaborn library which we had imported earlier. Just say regplot like so, in bracket x value will be equal to this guy here, actual data. Just say actual data, comma y value will be equal to this guy here, predicted data. And the data itself will be equal to this guy here, prediction results. Let us just copy this guy and paste him right here, I believe. So also do not forget to put these guys in quotes, this actual data and this predicted data in quotes. Make sure you put them in quotes or else this code won't work. And after that, let us just run our code and see what it gives us. This is the graph that is plotted down here. So this actual space here, the gray space with this line here, represent the actual data, and these other points outside this gray point represent the predicted data. So as you can see, our model is not that accurate according to this graph here. So this is how you can actually plot the predicted data and the actual data. So the last thing I would like us to see is to see how we can evaluate or use this model to predict future data or even manipulate it in order to get what we want. Now, in linear regression, a model is nothing more than just a simple function for evaluating a line. In this case, the model is just a simple line like this drawn on a plane. So this line here, from statistics, it has a y correspondence here and an x correspondence. And this y correspondence here can be gotten by this function y is equals to mx plus c. This m represents the gradient of this line. The gradient, I mean, if you take one point here and the next point, you take the next point minus the first point, that is y2 minus y1 over x2 minus x1. That is the way you find the gradient. So this is represented by this guy m here, and x of course are these values down here, and this c is the intercept of this line on this y-axis, the point where these two lines meet, that is this c. And so in linear regression, what happens is this: you have this y which represents the attribute or the value that you are looking for, and these x's correspond to the attributes that correlate to this y. For example, in our case, we are looking for the happiness score. This happiness score will be this guy y here, so I'll put him here, and these x's will be the other value that correspond to this happiness score. And you remember we got GDP per capita, social support, healthy life expectancy, and freedom to make life choices. So these will be the x's that correspond to this y. So this will be replaced here, x1, x2, x3. The function is like this when you have more than one attributes that correspond to y. And if this c is 0, That is, if this line comes up to this point 0, then you need not to include this c. And now this m, the way you find it in this model is very simple. For now, you just need to understand that this function is just y is equals to mx plus c, and if you have many attributes, it will be y is equals to m1 plus x1. That is the coefficient. These are known as coefficient that correspond to x, and then this c is the intercept. So the coefficient that correspond to x1 times x1, the coefficient that corresponds to x2 times x2, the coefficient that corresponds to x3 times x3, like that until you finish all these attributes, and then you add the intercept. So in order to get this guy, these coefficients and this intercept, so that we can find our function, or rather let me say our model, you just do like this. If you can remember, our model was regression dot, in order to find intercept, I just say intercept like so. Then I put an underscore at the end of this code, and then I'll run my code here. So I have a number printed down here. It is 1.099. So this is my c, this is my intercept. And now in order to find the coefficient, this m1, m2, m3, m4, the way I'll do this, I'll just say regression like so dot SOEF coefficient, then an underscore like that, then I run this file. Now these are the coefficients that correspond to this m. I'm only now need to fit this coefficient to this function here in these m's, and then I'll be done with my model. The way I can print this coefficient to be more professional and more clearly and even more visually attractive is I'll just come up here, and where there is x here, I'll just copy this guy, and just down this x, I'll just form this another variable x2, which is the same as this x, and I just remove this dot values. As simple as that. I'm removing dot values because when I call this function now, it won't return an array of value like this other one. It return data frame with these titles, and I want to pick this title. I don't want to use this one because this one does not return titles. So I'll just come down here and I'll just say something like this. Let me just say coefficient underscore names like so, and I'll just say equals to. Now I'll use the pandas data frame. I'll just say data frame like so. Inside here I'm going to pass a list, and inside this list I'm going to pass a function by the name zip, and this zip function I'm going to get this guy by the name x2 that we have just formed up here, this guy x2, and I'm going to snatch his column. Columns are just title for the data that is inside this x2, so it will pick the title of every column. And then the next data that I want to associate him with is this guy by the name coefficient, so I just pick that guy and paste him here. And then the last function that I'm going to pass here will be columns, and in this case should be, let's say, features, comma, and this other guy. So these are just title for all these guys here, so it will be features and coefficients like so. I believe there is not an equal sign there, and so I just print these coefficient names so that you can see what has happened here. So you should include an equal sign here. I forgot, you should include an equal sign here. So this is what is printed when I run my code. You can see we have features, and then on the other side we have coefficient. These are the titles that I've just included here. And then here we have GDP per capita. We have the coefficient values here. Social support, the coefficient values here. Healthy life expectancy, coefficient values here. And lastly, freedom to make life choices, the coefficient value is here. So our model now will be something like this. Let me now just copy this guy here. that I say will come back to replace him here. So let us do something like this. So we'll have happiness score is equals to M1, which is this guy. Copy this guy and come and paste him here. And then M2 will be this guy for social support. Come and paste him here. M3 will be this guy for healthy life expectancy. Come and paste him here. And lastly, M4 will be this guy, and come and also paste him where? Here. So let me just do something like this so that you can actually see clearly what is happening here. So I hope you are seeing what is happening here. So this is our model, which is happiness score is equals to 0.899155 times GDP per capita plus 1.66784 times social support plus 0.866244 times healthy life expectancy plus 1.745049 times freedom to make life choices. Also, I need to include one more thing here, and that is the intercept at the end of these guys. Just write plus, and then go up here. There is this guy intercept here. Copy this guy and just come and paste him down here, right here. And so like so. So our model will be like that: M1, X1, M2, X2, like so, and the intercept. So what is the value of this model? When considering the value of a model, we have three main advantages of a model when doing a research. Now, for example, in this model, the first thing we can be able to deduct or conclude from this model is this what we call descriptive analysis. Descriptive analysis means this model defines how these variables are related. If these coefficients here would have been 0, then we could safely conclude that this happiness score is not related to any of these attributes. So that is the first value of a model. It gives you the assurance, or rather the confirmation, that these attributes here, GDP per capita, healthy life expectancy, social support, and freedom to make life choices, are directly correlated to this guy happiness score. Number two, it helps you in what we call predictive analysis. And in predictive analysis, this is what happens. You try to fit random values here in these attributes and see what will be the result of this Y attribute. For example, assuming that a government is doing a research and came up with this model, it will try, for example, to fit random values in this GDP per capita, healthy life expectancy, and maybe let us say social support, and see how these values will affect the happiness score. And as a result, they will come to a conclusion that if we, for example, raise the GDP per capita and lower the social support, then the general happiness of the country will rise. That is simply what we call predictive analysis, trying to fit random values in X in order to estimate the future value for Y. What about prescriptive analysis? Prescriptive analysis is a situation whereby you define a constant value here in happiness score, or rather this value Y, and then you force values in this X that will correspond, or rather will add up to this Y value. Let's say, for example, the government want to lower the happiness score for a certain county. What they will do, they will just put a lower value here, and they see how can they manipulate this other X attribute so that they can fit this value. That is what we call prescriptive analysis. And that is the end of our project. Congratulations, you have just managed to build your first model in data science. Even so, you are now ready to proceed to advanced machine learning projects.